Would you like to know how to find the maximum and minimum values of a function of one variable within a domain? If so, stay tuned. Alright, so my name's Sam, and I'm going to be tutoring in Mathematica, but really what I do is mathematics tutorials from within a Mathematica window. So what you learn is computation and mathematics at the same time. Okay, let's get into it. So I'll open up a Mathematica notebook, and keep in mind that you can get Mathematica for free, Mathematica 10, if you have a Raspberry Pi. Okay, so in one of my videos you can find information about that. Alright, so first of all, let's consider a simple polynomial f of x, x cubed minus 5x plus 6. And we have a domain from -3 to 3. Alright, so first of all, let's enter this and say plot it so we can have a look at it. So f equals x cubed minus 5x plus 6. And I'll plot f from -3 to 3. Right, so this is the domain that we're looking at. Shift enter. I didn't say what the variable x, okay. Shift enter, and here we see our cubic. All right, now this problem is asking within this domain from -3 to 3, it's asking for maximum and minimum values. All right, now there are kind of two questions in such a problem. You might want to know what are the local maximum and minimum. So I'll just point these out. This top is a local maximum because it is in that local area, you see. And this bottom over here is a local minimum. All right, now if we are considering this within the domain from -3 to 3, you'll see that this point down here, when x is -3, that's the lowest overall within this domain. All right, so this we call a global minimum because it's the minimum overall within that domain from -3 to 3. Now let's scroll up and have a look. This up here is a global maximum. Okay, so how do you find these if you don't necessarily know what the graph looks like? Well, what you want to do is you want to find all of the local max and min, determine whether or not they are whether they are max or min, and then what you want to do if you're looking for global maxima and minima is you would compare those with the boundaries of your domain. So in our case, we would compare this point here, this local maxima, with this endpoint and the other one down here. All right, and we would compare the value of the function there. And if you do that, well, you see just by looking at this that this one over here at +3, that's the highest one, and so that is the global maximum. Okay, but we cannot just always do this by looking at a graph. You want to be able to do this by calculating. Okay, so we do that with calculus. Now the PDF has gone away, so I'll pull it back up. Okay, all right, so now we don't necessarily have to follow the code that's given there. So we've already got f in memory. So the next thing we want to do is calculate the first derivative. All right, so we can do that with the uppercase D function, which takes the first derivative with respect to whatever letter we put in there. So in our case, let's put in an x. So we want to differentiate this function with respect to x. Now, of course, you should do this by hand, okay, using the rules of differentiation. But as this is a Mathematica tutorial, we are going to focus on some of the computations, okay? All right, so shift enter, and what we get for the first derivative is 3x squared minus 5. Okay, now I will scroll to this, click there, and then I'll press enter so that it comes out in a way that I can use. Okay, so I can do something with this now. Now, the next thing you want to do, so look, we should comment this, right? Okay, so I'll write a few comments. Taking first derivative of f. Okay, so that's what we've done there. Now what we're planning to do in this line is to solve, right? So let's write that in comment form, solve f dash of x. All right, so this is the notation for the first derivative in Newton's notation. Okay, so we're solving this equals 0. All right, so now this is just a simple quadratic. So of course what you want to do is just solve this the usual way by hand. All right, you move the 5 over to the right hand side of the equation, you divide by 3 and you take a square root. Okay, but as this is a Mathematica tutorial, I'll show you how to do this with built-in solve function. So if we just write solve this equation, now notice I've got 2 equal signs, right? That's the syntax for when I'm not setting something equal to. Okay, so solve, and we're solving 4x. All right, shift enter, see what we get. Now this gives us plus or minus the square root of 5/3. All right, so okay, that's great. Now what if you wanted a numerical answer? Well, all you have to do is put an uppercase N in front of this. Okay, and what if you wanted more decimal places? Well, I think from memory all I have to do is add some more. Let's see, yeah, that does it. Okay, so you can get as many decimal places of accuracy as you like when you do this. Now, let's see. Okay, so probably we only want a few, so let's go for 5. Okay, so the next thing is for us to do is to interpret what these are. So let's go back. Remember these numbers, plus or minus 1.29 something. Okay, now have a look here at this graph. Minus 1.29. Now where would that be? 1.5 is somewhere in here. 1.29 might be here. So that says that the turning point, the place where the derivative is 0, and remember that corresponds to a horizontal slope. Okay, so when the slope is horizontal, so we've got turning, x is equal to minus 1.2910, blah blah blah. Okay, the same over here. When x is equal to plus 1.2910, etc., we have a horizontal slope of the function. How do we know that? Well, because the first derivative corresponds to the slope at a given point. Okay, so if we solve for when that slope is equal to 0, that must be a turning point in the function. Okay, so now that we've found those, let's go ahead and find the y value. Right, so if we've got x on the horizontal axis and y on the vertical axis corresponding to f of x, then we want to find that in order to compare those against the possible global max and min. Okay, so let's go ahead and find the y value. So for that, I think I would prefer to use the surd form. Okay, so I'll go back and take these as plus or minus square root of 5/3. Actually, you know what? I can just click enter, and I can instead say replace all f, and I'm going to replace the x in that function of x with minus the square root of 5/3 and plus the square root of 5/3. Okay, so I think to use this I need to get rid of some brackets. Get rid of some brackets, and let's try this. Shift enter. Okay, right, so we can probably only do this one at a time. And I'm guessing, yeah, okay, so let's get rid of one of these. Okay, there we go. And now let's try this again with it being plus. Okay, there we go. All right, so this gives us 2 points. 2 points where we have possible max or min. We've got to find out whether or not those are maxima or minima. Okay, so copy this, paste. And then for this one, we had minus square root of 5/3. Okay, alrighty, so now that we've got these, we can see that at this point here, this is higher than this one because of that plus, right? The difference between these two is there's a plus there, there's a minus there, right? So this one's got to be higher. All right, so we know that, but let's determine mathematically whether or not we have a maxima or a minima. Okay, so to do that, let's go back first of all and have a look at this graph. All right, now if you are thinking about the slopes and how they change. All right, so let me get my hand out and try to match. Maybe I want this hand. Oh, look, it might not work. Okay, so here we go. I've got my hand like a tangent. All right, now what happens when I move this? Okay. So, all right, so if I have the slope increasing, you see, I'm trying to do that here around the local minima that I see. Slope increasing. See, going up. Now, what does that mean? Well, the derivative of the first derivative, meaning the second derivative, well, if that is positive, that means that the slope of the function is increasing as x is increasing. Okay, so a positive second derivative would indicate a local minima. All right, and likewise, a negative second derivative would indicate a local maxima. Okay, so we want to take a second derivative and evaluate the second derivative at the point where we suspect there is a turning point. Okay, well, we really have found a turning point, but we need to classify it. So, all right, so let's come down here in a new cell. Right, so we've already taken the first derivative, but I'll just, for convenience sake, put it back in. All right, now I want to differentiate this again. Okay, so I just apply the same derivative operator to the first derivative. All right, shift enter. Okay, so this is saying that the second derivative is equal to equal to 6x. All right, so I'll note that. Second derivative of f of x is 6x. Okay, so now that we have that, we need to evaluate the sign, as in plus or minus, the sign of the second derivative at these turning points. Okay, so now I'll just say replace all 6x, and I want to first of all, let's look at replacing the x with minus the square root of 5/3. Okay, shift enter. Oh, whoops, misspelled. Okay. All right, so here we have what we're after, which is minus 2 times the square root of 15. All right, now you ask yourself, is this plus or minus? Well, it's minus, okay? So what does that say? All right, so let's note, since f double dash of x No, we know the value, right? And it's this number right here. Okay, now the sign is negative, comma, we have a local maximum at the point. Let's have a look. What was that point? This one right, no, this one right here. Okay, at the point minus root 5 on 3, 6 plus blah blah blah. Okay, so that we have deduced is a local maximum. All right, now that agrees with our graph right here, local maximum right here. Okay, now let's find out that this other one is a local minimum using the same technique. So we'll scroll down. Okay, so all we have to do now is replace x with plus the square root of 5/3. And we get a positive number. Okay, so we can just copy this out and change a few things. Since f double dash of plus this square root is positive, we have a local minimum at the point plus 5 on 3, and then this was, if I remember right, 6 minus this other number. Okay, so that's what we have so far. All right, now that we found and classified the local maxima and local minima within that domain, we now need to look at the endpoints of the domain in order to deduce which one is a global max or min. Okay, so that's not too hard, because what we do is we just sub in, so I'll just say replace all. Now look, I'm using replace all because I don't want to have to go and enter something into memory, so it's convenient to just use replace all. Okay, so I want to replace x first with minus 3. All right, shift enter, and I get minus 6. All right, now let's record this as a point. Okay, so in comment form I'll say point minus 3 minus 6. All right, this is one of the endpoints of our domain. And likewise, I want to do that with the other end. Okay, so plus. All right, so we have another point. Let's say points plus 3 and then plus 18. Okay, so now what we do is we look at this minus 6 and we compare it to our local minima, right? Which, remember, was this. Right, so we just have to compare these two numbers. Okay, so how do we do that? Well, look, I mean, you can just do so by looking, and you can say, well, look, you know what? Let's just calculate, right? This is a Mathematica tutorial, so let's just calculate. Okay, so we'll just take the numerical value of this number right here, and we're comparing that with minus 6. All right, so clearly minus 6 is the lower number, right? Okay, so now I'll just confirm that by saying minus 6 less than. Okay, you can take that as a question and it'll say true or false. So let's have a look. True, indeed true. So what does that mean? It means that this point right here is a global minima. So let's note that down. We'll turn this into a comment. Since we have minus 6 less than that other number, this point right here corresponds to a global min, and I'll write min for short, on the domain minus 3 to 3. Okay, now what about the maxima? So all we have to do is do the same. Compare this number 18 to this number right here. All right, so I'll copy that out. And I suspect that 18 is the bigger number, so I'll ask that question of Mathematica. Is 18 greater than this number? All right, yes, it's true. So let's turn that into a comment. Since this number is greater than this one, we see that this point 318, and I can just copy this because I'll change just a few things. Okay, corresponds to a global maximum on this domain. All right, and we've basically solved that problem. Now, there are several other exercises in this set. Let's just have a sneak peek at them, but I won't do those. I'll leave those to you. All right, so here's some code. And then there are a bunch of other problems that you could try out. Now, they all follow a very similar recipe. Okay, now I'll just remind you, this booklet is available on my website. It's free. I'll try, if I remember, to put a link in the description below. It's called a YouTube course in Mathematica. Okay, that's all I have to tell you for now. So thanks for watching. If you're a new subscriber, thank you. I appreciate it. I'd like to grow this channel so I can help more people and help myself. So thank you, and I'll see you next time. Bye for now.